We don't often think about the conveniences we have.
Okay, so what store you guys want to go to first?
All of them. Well, okay, we set that cooking
And
store.
what do you want to do about lunch?
How technology has delivered the products we use, the roads we travel, the vehicles that take us from place to place. We also probably don't think about the raw materials and from where they came, or that much of it begins with explosives. And certainly, it seldom, if ever, occurs to us that commercial explosives are essential and necessary to our lifestyle. In fact, without explosives, the country would come to a stop. This program is called Explosives, the Power Tool. And it's about a valuable and indispensable product for which there really is no practical substitute. Let's take a look at that family again. Do explosives really have any impact on their lives? What about that car? Let's see. There's steel, copper, aluminum, zinc. All metals that come from ore dug out of the ground. Here on Minnesota's Mesabi Iron Range, ore has been extracted from the earth for more than 100 years. What could be backbreaking work is made easy by explosives. Even this huge mechanical equipment can't accomplish what explosives can. Explosives are the only conceivable tool for many of the jobs that must be accomplished here. Cars rely on petroleum. They require fuel, usually gasoline, and lubricants. There are plastics and synthetic materials, many made from petroleum. As finding oil underground becomes increasingly difficult, explosives play a valuable role. A small explosives charge is set off underground. Instruments measure the effect of the blast and gather information that will assist geologists in pinpointing likely spots where oil and natural gas reserves have accumulated. Later, when the well is developed, explosives will be used to perforate the well and cause the oil to flow. Pacific Gas and Electric needs to move billions of cubic feet of natural gas from Canada to California. A pipeline is the cleanest, safest, and most efficient way to do it. Again, the explosives industry plays a valuable role. One of the least expensive forms of energy known, explosives deliver tremendous power, exactly where it's needed. In this case, the pipeline trench. And of course, cars travel across roads and highways, over bridges, and through tunnels. For a home to be built, we dig a hole, pour a foundation. But for a building like this, or for a skyscraper, site preparation is much more complicated, often beyond the capability of mechanical earth-moving equipment. Even computers begin with commercial explosives. Out of mines come gold, silver, and copper for the electronics, silica for the glass of the video tube, rare earth to make the phosphors on the video display. Then there is the electricity to run it. From deep in the ground comes the coal, blasted out of the mines to fuel the electrical power plants. Commercial explosives help build the great dams used to generate hydroelectric power and to control flooding. And this electricity is basic to almost all industries and most jobs.
That was your assignment in class, to be the cleanup girl?
Blasting mines products that become fertilizers for food. Well, you get the idea. It's difficult to encounter anything that isn't somehow originated from or improved upon by the skill of the explosives engineer. Explosives are very powerful, yet they are generally insensitive until ready for use. Dynamite is still used today, but newer products are generally cheaper and less sensitive than dynamite. Now, most explosives are delivered to the work site as bulk product, often in tank trucks, although sometimes in smaller quantities in bags and boxes. The most frequently used products today are ammonium nitrate mixed with fuel, called ANFO, water and oil emulsion explosives called emulsions, and water gels. The manufacture, distribution, transportation, and use of all these products is closely regulated by federal and state governments. Each blasting job presents a different challenge. Teams of geologists, civil engineers, surveyors, and explosives engineers work together to solve the problems. The geology of the area must be analyzed to accurately determine the amounts of explosives required. Different rock types require different explosives or amounts of explosives. The distance from the open face to the borehole must be accurately determined to prevent fly rock, rock propelled out of the blast area. The next step is drilling. The engineer's calculations have determined the location of each hole, the depth, and the overall drilling pattern. Before loading, each hole at the blasting site is rechecked for depth, water content, and location. Then, primers are lowered into the hole. Bulk loading is fast and simple. Each hole has an initiator or detonating cord to provide a delay interval. This delay sequence helps keep resulting vibrations within safe limits, controls the movement, and assures proper breakage of the rock. Then the hole is stemmed with crushed stone. Blasting mats may be applied to hold down fly rock. The ground may be dampened down with water to reduce dust. Last-minute checks are made of monitoring equipment, which will determine if noise levels and vibrations are within established limits. The site is cleared, the area is made secure, the alarm is sounded, the signal is given. There is fire in the hole.
Fire in the hole.
When detonated, the explosives turn rapidly into gas, exerting pressures as high as 4 million pounds per square inch. The explosives do their job quickly, economically, and safely. Raw materials formerly locked within the earth can now be freed with the concentrated energy of explosives. Though mighty, explosives are controlled safely to do the work precisely and accurately. With incredible strength in a small package, commercial explosives are the hardest working power tool of all.